Mammals aren't particularly new. They have been around in some form or another since the Permian period. Of course, all the way back then, they may not have been entirely true mammals, but you get what I'm saying. Though the true mammals that emerged during the Mesozoic era did not reach the heights they do today, they thrived. After the extinction 66 million years ago, mammals took the hell off, even relatively soon after most of the non-avian dinosaurs died out. Like thousands to a million years after, mammals exponentially increased in size, mass, and diversity. The halfway point between the dinosaur extinction and today, the Oligocene epoch, the end of the Paleogene period, and about 33.9 to 23 million years ago, saw a very interesting and very different world ecology than both today and during the time of the dinosaurs. It was not the hothouse tropical world of the beginning of the Paleocene epoch and saw a general cooling trend resulting from a warm climatic optimum of previous epochs. It saw a global cooling effect that drastically changed many habitats, sending plenty of animals to their evolutionary graves. One of those animals belongs to a very unique lineage that was moderately successful from the end of the Eocene epoch to the middle of the Miocene, the entelodonts. These mammals, which were related to hippos, whales, and a bunch of extinct offshoot cousins, culminated in forms as large as the bison of today's Great Plains. Before I get into the nitty-gritty of what is known about the largest of these terminator pigs, we should take a trip through the semi-murky nature of its discovery and the validity of its many, many names. Yes, unfortunately, the largest of the hell pigs was one of the many mammals embroiled in the Bone Wars. All thanks to Othniel Charles Marsh and Edward Drinker Cope and Seethe. Draining from the early Miocene Appalachian Mountains are the streams and creeks which flow through the woodlands of New Jersey until they reach the blue Atlantic. Fed by mountain lakes and aquifers, these meandering waterways provide a much-needed source of liquid to the parched lowlands of the summer. Flowers and grasses shoot up through the cracked ground as the fluid product of the rainy season in the mountains turns the earth a deep brown and the tree leaves a healthier emerald hue. Though the temperature still peaks at over 32 degrees Celsius, 90 degrees Fahrenheit, many large herbivores can be found in these coastal forests. Gigantic, two-horned, semi-aquatic rhinoceros settle down into the waterholes of clearings. Three-toed horses race through the woods and munch on tree leaves as peccaries squabble over roots and burrow sites. Extinct, distant relatives of modern mouse deer, with two horns at the back of their skulls and a branching one at the front of their snouts, compete for mates and territory, warily checking the surrounding trees every few minutes for signs of danger. In the seas, multiple species of gargantuan sharks vie for chow with ancient relatives of sperm whales, while other species of whales bask and play near the surface, their calls heard for miles. Mollusks scavenge on the sea floor as fish schools swim along. Back on land, a group of peccaries jog through their favorite mudhole, through an open patch of grass and flowers. The size of modern javelinas, these omnivorous mammals are often left to their devices by predators and other herbivores, weary of sustaining an injury from the peccary's large front tusks. Even the rhinoceros, the largest animals to roam these forests, are weary of the smaller mammals. As the peccaries cross the opening in the forest unaware, a huge predator stalks them. The gleaming eyes of this colossus give off the faintest light on the predator's distorted muzzle. Covered with scars, cuts, and the occasional protuberance, it would appear that this creature is of another nature from the other mammals of early Miocene New Jersey. However, it is nonetheless the largest mammalian predator to stalk this forest. This is an entelodont, a relative of the group of mammals which includes hippopotami and whales. However, the grisly, misleadingly hog-like appearance and terrifying predatory behavior of this odd mammal has given it the more ominous name of terminator pig. The massive front teeth of this humongous beast are rooted into its robust, meter-long skull. Its large body, built with immense shoulder muscles and powerful hoofed limbs to overpower its quarry, slopes down into a small tail tipped with fur. From the bushes, the terminator pig charges at the peccary group, which scatter in fear. However, the large carnivore has outplayed the smaller tusked mammals and has snagged the belly of one peccary on its canines. As blood loss takes its toll, the panicked and snared peccary tries at its large attacker with its front teeth, scraping the terminator pig's chin. The counterattacks are of no help to the peccary, who soon dies in the jaws of the larger mammal. With a single bite, the entelodont devours a large portion of the peccary's gut, though it will stash away the rest of its kill in a hole created by the roots of a fallen tree which the carnivore inhabits. What type of predator would do this? Let's take a closer look. Description: let's bring in Mr. Man from Animal Planet's The Most Extreme to get a good idea of how large this animal truly was. Daeodon was the largest member of its group, the entelodonts, reaching the size of the largest living bison. This means that the largest Daeodon skulls measure around 90 centimeters, 3 feet in length, with the largest individuals standing about 1.77 meters, 5.8 feet tall at the shoulders, with a full body length of 3.6 meters, 11 feet. They may have weighed in at a ton or more, and most likely more for the larger ones. Thanks, Mr. Man. If we take a look at the skull, we will see something truly horrific and truly unique. Its skull was different than its relatives in a few key ways. Most relatives have huge cheekbone phalanges that splay out from the sides of the skull. They also usually have huge knobs jutting out of the jaw at various points along its length. In Daeodon, all of these traits are reduced. It has a small knob near the midline and front of the lower jaw, with some specimens having a small pair of knobs in the middle of the jaw. Their cheek phalanges are also heavily reduced to small rounded things that point downward from the eye socket. As you can see, the skull has a very tall sagittal crest, indicating large jaw muscles to power the extremely thick jaws, which are studded with a Swiss army of bulky teeth. The teeth at the front of the jaws were round and conical. The canines were huge and pointed. They were followed by toothless spaces and a few more blade-shaped teeth before they transition into more traditional omnivorous or herbivorous molar teeth at the back of the jaws. Daeodon, unlike some of its relatives, also possessed a comparatively lightweight neck given the size of its head, with muscles and tendons linked to the tall spines of the thoracic vertebrae, similar to modern-day bison and white rhinoceros. The neck was obviously strong enough to hold up that noggin and deliver all sorts of damage to whatever the hell it wanted. Pole vaulting its body across the ground were 4 very light limbs, ending in 2-toed, hooved feetsies. What is actually remarkable when we take a look at Daeodon's limbs is just how closely they have convergently evolved to match the bones of the legs of bison. Daeodon seems to have larger shoulder blades and a thinner and more bent radius ulna, but the hand, feet, toes, and finger bones are almost identical in their lengths and how they are arranged to those bones seen in bison. You've got that little smashed up bit of hand bones there, then the longer bones there, the finger bones here, and then the ungual or claw bones, which would have been capped in keratinous hooves. The back limbs have the same proportions even with that same weird calcaneus that bends backwards like that. Then of course we've got an unremarkable tail. Taxonomy. So I unfortunately had to let the oddly pig-shaped cat out of the bag early in this video, in that Daeodon is an entelodont. That's not always how it has been, though unlike some groups of fossil animals, the name for the group and a moderate understanding of that group was uncovered relatively soon after its initial discovery, no doubt thanks to the fervor of the Bone Wars. By that, I mean that the entelodonts were not seen for what they were until a few decades after the discovery and naming of Daeodon and other terminator pigs from Europe and Asia. As we have already learned, Edward Drinker Cope established the genus Daeodon in 1878. He identified it as a perissodactyl and believed it was linked to Menodus. Perissodactyls are the odd-toed ungulates, your horses, tapirs, and rhinos. Menodus was a superfluous dubious name then given to remains of the Brontothere Megaceraps, all of which is far removed from the true classification of this huge bison-humped pig beast. This classification remained in place until the description of Elotherium culcansii in 1905, a very similar and considerably more complete animal from the same rocks as Daeodon. Remember that Elotherium was the dubious name a species name was tacked onto by Othniel Charles Marsh plenty of decades prior to all of this. O.A. Peterson swiftly designated this Elotherium a species of Daeodon in 1909. As a result, Daeodon was reclassified as a member of the family Entelodontidae. Thanks to Daeodon's placement among the Entelodontidae as one of, if not the largest members, we should take a brief diversion to get an idea of how Entelodontidae was formed. The first entelodont fossils to be named were described in the 1840s. Entelodon magnus, a European species identified by French paleontologist Auguste Aimard, was the first entelodont species known from excellent remains. Although most authors thought Aimard's account was written in 1846, a citation inside the piece reveals that it was not, instead being published in 1848. Around the same time, August Pommel, one of Aimard's colleagues, named another fossil as Elotherium. Pommel most likely published this work in 1846 or 1847, with reprints beginning from 1848. Entelodon and Elotherium are undoubtedly synonyms, albeit fossils from the latter are incomplete and gone, and those from the former were most likely described later. Almost all historical and current authors prefer to use Entelodon for clarity, even though it would not take priority under strict nomenclature requirements. The name of their related family reflects the mistake of priority between Entelodon and Elotherium. Elotheriidae was named by Edward Richard Alston in 1878, while Entelodontidae was named by Richard Lydekker in 1883. As with Entelodon, practically all paleontologists prefer Entelodontidae when referring to the family. More entelodont fossils were discovered in Europe after the misunderstanding between Entelodon and Elotherium. Beginning in 1850, large entelodonts were described from North America. However, most new taxa were subsequently merged into Archaeotherium and Daeodon. Because of the large number of fossils unearthed at the beginning of the 20th century, entelodont skeletal anatomy was well characterized. The earliest entelodonts were described with Sir Richard Owen's identification of artiodactyls as a natural group. Initially, entelodonts were thought to be actual pigs, but as more fossils were uncovered, it became obvious that they had a lengthy evolutionary history distinct from pigs. Regardless, entelodonts were often regarded as basic artiodactyls, with unspecialized bunodont teeth, in contrast to the robust adaptations for herbivory found in more advanced ruminants. Several names were coined to describe living and extinct bunodont-toothed and non-ruminant artiodactyls, including the Omnivoria by Richard Owens in 1858, the Bunodontia by Richard Lydekker in 1883, and the Non-ruminantia by William King Gregory in 1910. For clarification, bunodont is a dentition condition where the animal has molar teeth with crowns in the form of rounded or conical cusps, like this. Some scholars thought entelodonts were too primitive to be compared to present bunodont artiodactyls. Entelodonts were classified as paleodonta in these investigations, along with many other extinct groups. Choropotamids, Cebocorids, and Helohyids were commonly connected with entelodonts and were even thought to be probable ancestors in certain cases. Entelodontoidea was later designated to comprise Entelodontidae and its presumed closest extinct relatives. Entelodontidae is widely regarded as the only family within Entelodontioidea in recent studies. Several studies claimed that entelodonts were related to living pigs, peccaries, and hippos. In relation to a pig-like anatomy, many groupings have been established and named, with names such as Swina by John Edward Gray in 1868 and Suiformes by Otto Max Johannes Jekyll in 1911, being used in various situations. Swina is still used in a restricted sense as a prominent artiodactyl suborder that includes Teasuidae, the peccaries, and Suidae, the pigs. Early artiodactyl cladistic analysis identified Entelodontidae as the sister taxon of a Tasuidae plus Suidae clade. This seems to validate the frequent analogies of entelodonts to pigs. While entelodonts have traditionally been categorized as members of the Swina grouping, Michelle Spalding, Maureen O'Leary, and John Gatesy published their work on these animals in 2009, which found that entelodonts are more closely related to whales and hippos than to pigs. The position of whales in relation to artiodactyls and mesonychians changes dramatically depending on whether the huge mysterious mammal Andrewsarchus is included, and it has been proposed that Andrewsarchus is an entelodont or related to whales, and so it is that Daeodon was not immediately recognized for being an entelodont until much more of it and close relatives were found. Yet some fragmentary members of the group and a general but vague idea of that group had existed before Daeodon was discovered. But how is Daeodon organized within its own group? The precise relationships between Daeodon and other entelodonts are not super well understood. Some authors, such as the Spencer Lucas team back in 1998, consider Daeodon's greater morphological similarity to Parentelodon rather than earlier North American entelodonts such as Archaeotherium to be evidence for Daeodon being a descendant of a late Oligocene immigration of large Asian entelodonts to North America. This would make Daeodon a later immigrant to the Americas, ironically mirroring the largest apex predators of the latest Cretaceous of North America. However, the presence of different Archaeotherium specimens with characteristics similar to those seen in both Parentelodon and Daeodon suggests the hypothesis that both genera descended from a shared ancestor in North America. For those wondering, other members of the Entelodontidae include Brachyhyops from the Eocene of Western North America, Mongolia, China, and Kazakhstan, which has been known to science in some form or another since 1937. There is also Cypritherium from the Cypress Hills Formation of Saskatchewan, which was found in 1887. We of course have the namesake Entelodon, which was in between the sizes of Archaeotherium and Daeodon, and is known from 37.2 to 28.4 million-year-old rock deposits across Eurasia. Eoentelodon, named in 1958, comes from the Middle Eocene of China and was about the size of a modern pig. There's Parentelodon from the late Oligocene of China and Pakistan, named in 1964, and may have been the only other entelodont to reach the size of Daeodon. Finally, there is Proentelodon, which may or may not even be an entelodont, and was named in 2008 based on fossils from the Middle Eocene of Mongolia. Ecology. Daeodon had a large range in North America, with many fossils discovered in agate fossil beds, a transitional habitat between thick forests and open prairie that was likely a significant cause of its demise in the Middle Miocene. It adapted to grasslands with a more cursorial body plan than more basic entelodonts like Archaeotherium, with no dew claws, proximally joined metacarpals, and shoulder musculature akin to bison. The Agate Springs bone bed was located in a floodplain with wet and dry seasons. Daeodon coexisted alongside little gazelle-like camels, the huge browsing Calicothere meropus, many predatory coyote to wolf-sized amphicyonids that lived in packs, land beavers like Paleocastor that filled the ecological role of living prairie dogs, and hundreds of small herd-living rhinoceros. The rhinos died in large numbers during the dry season, but Daeodon remains are few, suggesting that they were neither sociable nor particularly drawn to carrion. Daeodon, like all other entelodonts, was omnivorous. The patterns on the enamel imply consumption of nuts, roots, and vines, as well as meat and bone. The apparent resemblance to peccaries, hippos, and bears suggests that Daeodon might have eaten a broad variety of vegetation. Because the dry seasons in North America may have been brutal at the time, they may have supplemented their water intake by consuming grapevines. The degree of its carnivory is debatable, although tooth wear indicates that they specialized in smashing bone and shredding flesh, and bite marks on Calicothere bones indicate that they hunted or scavenged big animals. According to Scott E. Foss's Systematics and Paleobiology of the Entelodontidae, published in 2001, its head was far too heavy to be effective in taking down large prey, so it must have relied solely on scavenging. But its bison-like adaptations for running, stereoscopic vision typical of predators, and evidence of predation in entelodonts call this interpretation into question. The ambiguity of their diets shows that they were opportunistic omnivores akin to bears, consuming whatever they needed depending on the situation. Entelodonts engaged in intraspecific face biting, as evidenced by teeth marks on their skulls. Perhaps males would struggle for supremacy, presumably using their mandibular tubercles for protection, as well as muscular attachments. Archaeotherium has sexual dimorphism of the jugal projections, and with a lower Daeodon sample number, such dimorphism cannot be ruled out for Daeodon as well. If dimorphic, the larger jugals were most likely used for display, supporting massive preorbital glands similar to those found in forest pigs for chemical communication. For more interesting stories about nature, the history of life, or what goes bump in the night, subscribe, like this video, drop a comment in the comment section below, and hit the bell icon to stay in the know with everything Edge. Thanks for watching. Special thanks to Elephant Tier patrons Abby Smith, Arda Bayer, Biotiverse, Cherry Shaw, Chris Frampton, Christoph Hubbinger, Dinosaur, Ed Peretz, Isaiah Garza, Jax the Hacks, Natty Cat, PA Brew News, Ray, Rudy Redgrave, Smiling Walrus, Staniforth Hopkins, Steve Bradshaw, Thea Svensson, and Extraterrestrial, as well as my Tapas tier Tyrannosaurus patrons, Admin, Antron, Aphid Kirby, Cyber, Dana Manchester, Danny Van Heck, Henry Brennan, Iberospinus, Iron Bladesman, Joshua Mana, Panic, Radio 404, Robert Kessler, Ruben Zachariah, Swaffles is Weird, Teeny Dragator, and The Dogman.